Ladies and gentlemen, it's a pleasure to be back here in London. I was here in the previous one, which was that 2001 or something like that? It's a long time ago. And I'm really happy to see how the skyline has changed, and especially because we had such a big role in the change of this skyline, enabling this change here in London. We see a lot of new buildings here, new heritage to London, blending in well, actually, with the older buildings which are here in London as well. And I'm going to present to you technology that will give you a good view on how we are going to keep those new buildings and also those older buildings compete with each other, that they keep the city vibrant. So let's have a quick look at that. I'm first going to look at the trends which we have with people flow, how these people move in the building, and trends that affect that people flow inside the building. When we look at tenants, we can see that they are expecting more comfort, more convenience, more security as they use the equipment and as they move through that building. That's exactly what they expect from us. When we look, for example, at the building owners, they are looking for value. We heard that in the plenary session this morning. They are really looking for value, ways of branding their building, ways of looking how they can get more out of it. They want their buildings to be adaptive in the future. They want them to be efficient, and they want to have them manageable. Another big trend which we have now is digitalization. Still, at this moment, the majority of internet traffic is actually between people. But machines are taking over a large part already. In 3 years from now, we expect that 80% of all internet traffic is going to go between machines. They're talking with each other. They're communicating with each other. Not just machines, devices as well, all kinds of devices. And this means that we have to find ways to get them interlinked in an intelligent and a very, very good way. We are at the emerge of the smart city at this moment. Very important as well are the ecological effects of those buildings. So we see a growing interest in eco-efficiency. Those buildings have to go for either LEED or BREEAM, yes, and of course as high graded as possible. This is important for your branding. This is important also for the future of the cities. The other trend, which is well spoken about here in the Council on Tall Buildings and Urban Habitat, is that the number of high-rise buildings is on the rise, both in number and in height. We see incredible increase in height and numbers. And by the way, they get more complex all the time. So how can this industry, vertical transportation, ensure that it's possible, that we have the best possible people flow for these more intelligent and higher buildings in the future? And that's what I'm going to talk about today. Let's look at intelligent buildings. Yep. We have a multiple number of tenants in these buildings. These are typically multi-use buildings. We can have combinations of offices, hotels, residential, shopping centers, and you name it. You could even have hospitals there. Yeah, you just name it. Yeah, it's going to be a very big mix of different tenants. And they all have their own needs. Yes, they all have different needs. So we have to look at those different demands, and these demands can change. They are different between different customers, but they can change actually sometimes within the same day. They can even change, in time. A new customer comes into the building and it changes, the demands change. So how can we look at making these buildings interact in the right way, in the wrong thing? Because some of these demands are sometimes very, at odds with each other. We want security, but we also want easy flow. Yeah, and that's difficult to combine, and you have to make sure that it works. So before I start going deeper into things, I will have a small video, and let's look at a small video first.
Digitization has dramatically transformed the way buildings function and the way people behave in them. Building operators face the dual challenges of ensuring that tenants can move around buildings as smoothly as possible while simultaneously providing improved security and access control. Con-Air's people flow intelligence solutions are designed to meet these challenges. Con-Air's access solution features a customizable access control system that's seamlessly integrated with the building's elevators. It ensures excellent standards of security and makes moving around the building as safe and as smooth as possible. Tenants can have their profiles stored in the system for convenient access. When a person enters the building, the system will automatically recognize that they're most likely heading for their home floor. Con-Air's destination control system significantly improves passenger convenience while boosting elevator performance. The new touchscreen destination operating panel guiding users to the most appropriate elevator means less crowded cars, shorter travel times, and fewer stops. Con-Air puts efficient elevator travel at everyone's fingertips. With our mobile application, passengers can make personalized elevator calls from anywhere in the building. While riding the elevator, passengers can catch up on the news and read important building information on Con-Air's info screens. Updating the screen content is easy with our convenient user interface. Con-Air's monitoring system provides real-time information for the building's elevator and escalator equipment. Data is available on transportation demand, traffic performance, and elevator capacity, while equipment status information helps you to respond rapidly to problem situations. Con-Air's people flow intelligence solutions not only enable efficient building management, they add real value to your property. Our modular solutions are designed to be scalable, growing and adapting according to your needs. And by choosing a complete solution from one partner, you benefit from simpler planning, installation, and operation. The bottom line? Smoother, smarter people flow.
Well, you saw 4 teams there, and you can see them here on the screen as well. There was access, there was destination, there was information, and there's monitoring. And typically when you talk about that with elevator companies, you get 4 different systems. What we have done now is we have integrated them all into one single platform. This means we are more flexible in the future. We can adapt much better. We can add functionality in a very, very simple way without having to need a hell of a lot of extra equipment to your building. Yeah, so it's going to be much more flexible. We call this single new platform Con-Air People Flow Intelligence, where we can get Con-Air People Flow Intelligence is in principle the brain of all these things. This puts everything together as one piece and interlinks everything automatically together with each other. So you don't need to do it in multiple systems. It's all one single system. So let's look first at access, what it actually means. Access. Well, you know, from us, you can get one complete system. It does the whole people flow system there together. So we have our own access system. It's based on a partner called Kaba. We chose this company for a very special reason. Now, what would you say if the company, your partner, would be working in 2 of the most secure positions in the US of A? Air Force One and the Pentagon. I think that's the right partner for us. Yeah, these people really know something about access. So our access control, based on their access control system, is going through the whole area where people actually move, people flow in that building, from the entrance to the lobby, to the elevator, to the office floor. yes, where all the devices are interlinked in that same access system. We focus on the people flow part of the access system. But have any needs in the future to continue a little bit further? For example, into organizational things. For example, things like car park billing, restaurant billing, depending on how you use it with your access card, time management, all these kind of things which are organizational, and you can think a lot of functions. It's easy to just go further with our partner. It's the same system, so it's a lot less of integration work to do. It's just there for you. No access or integration work to do further. Of course, we can work with third parties, other third parties as well, but then you have to do a lot of integration work. But with this, no integration work, also when you want to continue on your organizational level. Yeah, so all the additional you can easily get through our partner. No problem with that. So now let's go to destination. Just have a look at this. We are looking really at the optimal user experience. So it should be easy for everyone to use. Independent of culture, independent of age. And in touchscreens, to be independent in age, independent in culture, actually it's actually moving objects. Moving object. That is something every age, every culture does. We made our touchscreen perfect for swipe, because that's the modern interface at this moment, swipe. You can easily move large object with no effort at all on a touchscreen. But to be able to get it to work right, you need a certain size. 10-inch touchscreens are perfect for gestures, swipe gestures, and these kind of things. They are perfect for that. They are actually the right size. That's exactly what our usability studies showed us. The size is also important. You don't want, when you want something to be usable, you don't want it to disappear in the lobby and not be visible. Not be found. It must be seen, it must be found quite easily. That's the reason we've chosen a size of a square size of 300 by 300 millimeters. It's one single surface practically. Yeah, easy to clean. Real materials, glass and metal. Real materials. High quality materials. Glass is easy to clean. Doesn't scratch that easily. We've put the touchscreen on the right-hand side, sorry, the handicap parts on the right-hand side, easy to find, easy to see on the same surface, one single surface. The back end is a metal plate, a skate. What that does, we can fix it to any wall independent of how, unsteady the wall is. It creates a gap between, a shadow between. It is as if it floats. Architecturally, we don't want any, shifting colors or anything like that. We've chosen for simple black. One single color. Yeah, architecturally fits into practically anything you have in your building. The speaker we have put in that little gap between those two sides. Directional to the user who presses that access button. He can clearly hear it and minimizing disturbance to the sides, which is also important in these buildings. This is really, really special when you look at this. We've put a lot of effort in this to make it architecturally, usably right. You simply can't beat the contrast of white on black. That's just the best contrast you can ever get. Not only that, we have there 4 different interfaces, all based on easy swipe functions, easy gesture functions. For example, this is one. This is the slider. Just put your finger on that dot and move it to the floor where you want. Let it go, and that's it. It will give you your floor afterwards, and you know where to go. This is the list. Select from a list. Click on the bottom or slide it. Just any way you want, any direction you want. It's logical. Those objects become so easy to move. And then select your floor. Again, very soft, and just slide it, gestures. You can have a keypad. Again, just touch it quick. Very simple gestures. We can have the direct call. Just select that. Go, and you do that. It's easy, very easy to use. Very simple user interface, very clear. And the answer back can be an easy, identifier with an arrow, or a map showing you exactly where you are and where you need to go. So with perfect guidance as well possible. That is a beauty, but this is another one. The phone, the mobile phone. We have them here in London already. The place here will be the first one where it's really going to be operational. The same interface. Just select from where you want to go to where you want to go. And it tells you which elevator to take and where it is, and it's coming to you. That's it, and you know exactly what is happening. You want to do more? You can have an iPad on your desk. Just touch which floor you want to go to for the receptionist. And there we are. Just tell the customer, go to elevator C. Quite simple, through mobile division systems. In the future, you have a system where, for example, you have a party all of a sudden. It's not the destination system. We can add a few destination panels to your floor, or you only had one. Now we have an occasion there where you really need a lot more destination panels. Easy to do in the future. Just put a couple of the pads on the floor. Easy to use. Perfect. Very simple. Our destination system is built that you can do anything. From conventional control to destination control all over the place. The next thing is buildings are getting higher and higher and higher. And there's a lot of them. Here we can see, published by the council, the 20 highest buildings by 2020. 3 of them exist nowadays over 500 meters that are ready. We have been involved in 2 of them. That's a fantastic achievement. But these buildings have problems. The rope weight increases dramatically. But let's have a quick look at a video first.
Keeping pace with the growing demand to move more people ever higher requires far more than just gradual change. There comes a point when existing technology and solutions can be taken no further. A revolutionary breakthrough is then required if the needs of the urban environments of the future are to be met. As buildings rise higher, logistical demands rise with them. A typical ultra-high-rise building sees thousands of people moving around, each one using an elevator on average 6 times daily. That's around 50,000 elevator rides a day. This places huge demands on elevator technology. The moving parts of a single elevator carrying 24 passengers can weigh up to 27,000 kilos and consume 130,000 kilowatt hours of energy a year. The components used in high-rise elevator systems operate under highly demanding conditions, making durability a huge challenge. Elevators are also subject to severe strains such as building sway, which can put them out of service on windy days. It's clear that current elevator technology has taken us as far as it can, and that mere refinement is no longer enough. KONE's ongoing commitment to innovation has delivered a revolutionary solution, one that opens a world of new possibilities in high-rise building design. KONE Ultra Rope, a super-light rope technology that sets a new benchmark for elevator performance. With its durable, lightweight carbon fiber core and special high-friction coating, KONE Ultra Rope is the revolutionary breakthrough the industry has been waiting for. KONE Ultra Rope has been rigorously tested under the most extreme conditions and has been approved by independent third-party experts. This revolutionary new technology brings a whole host of valuable benefits. Not only does KONE Ultra Rope last twice as long as conventional steel rope, it's also less sensitive to building sway, adding up to a significant reduction in elevator downtime. With an elevator travel height of 500 meters, this lightweight rope cuts the elevator's moving mass by 60% and reduces energy consumption by 15%. When elevator travel heights increase in the future, even larger reductions can be achieved. Moving masses can be reduced by 90% and energy consumption by 45% for an elevator with a travel height of 800 meters. KONE Ultra Rope will take elevators higher than they've ever been before. In the future, it can enable travel heights of up to 1,000 meters, twice as high as what's possible with today's technology. This groundbreaking innovation will support the design of more sustainable, higher performance buildings that are better equipped to meet the demands of the urban environments of tomorrow.
Wow, 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 I would say. You know, this is just an incredible amount of reduction of weight. This is Ultra Rope. This is it, this piece of rope here. It's a lot lighter than steel rope. And it can take the elevator of the future to 1 kilometer in one go. That's 3 times the external height of the shaft here, 2 times higher than the building can nowadays go with this rope. And it will dramatically reduce the weight of the rope and dramatically reduce the energy consumption of those elevators. As you heard as well, it is less sensitive to building sway. Its frequency is just much higher than of conventional ropes. We will not be coinciding with the frequencies of the buildings anymore. And therefore, sensitivity to rope sway is practically gone. Life more than twice. It is fantastic. It's something we've never seen before. Let me show you a little bit what Ultra Rope can actually do in an imaginary building. Yeah? This is the weight, by the way, of the rope, of the total moving masses of an elevator, how that changes over height with Ultra Rope, the blue line, and with conventional ropes. And by the way, when I say conventional rope, I mean ultra strong steel ropes. So that's an incredible difference in weight. Here's a quick example of what Ultra Rope does for you. This is an imaginary building, 640 meters high, with 120 elevators in it, from which the maximum travel is 550 meters. There are 10 units in this building higher than 400 meters, and you can see those units there at the bottom. This imaginary building is actually based on a real building going up, but I just changed some of the values so the building is unrecognizable. But let's have a quick look. This is total rope weight for those 10 elevators only. With steel ropes, the weight of ropes would be 186,500 kilos. That is 9.5 fully loaded 20-ton lorries. With Ultra Rope, rope weight is down to 11,700 kilos. Only half a lorry. That's 9 lorries less in weight, in just rope weight for these 10 elevators only. And of course, that will have an effect on energy and on the total weight. That's 94% reduction in rope weight. The total moving mass of the elevator is 332,000 kilos for steel rope elevators. For these 10, the total moving mass, meaning counterweight car, rated load and those ropes, the moving parts. With ultra rope, this is down to 157,000 kilos, 45% gone. A tremendous reduction. Energy consumption for those 10 units is close to 1,200 megawatts, and I'm saying megawatts here. It's a lot of energy. With ultra rope, this is down to just slightly over 1,000 megawatt hours. Add on top of that the cooling which you need, because this energy is lost inside the building. You need to cool that out of the building. You need 30 to 50% more from that amount to take it out. Your savings will be between 15 and 45,000 depending on the energy costs and depending on the future where the energy costs are going. It is tremendous. This is another big one. The starting line current of the biggest unit in these is 1,125 amps. With ultra rope, this is 25% less, 835. Depending on your riser configuration and your emergency power, you can save between 400,000 and €1,000,000 for those 10 units only on your riser equipment systems. With these cutting-edge technologies, we are ready to face the future. We are ready to make those buildings really work. Thank you.